Welcome everybody to this new appointment of the Future Materials Encounter series, a program which has received the support of the Innovazi Lab of Creative Industry Funds NL, Click NL on behalf of the Ministry of Education, Culture and Science. The material we're exploring today, as you might guess, is Mycelium, which will be presented today by Anaïs. Who came here from Grown Bio, a company who has been developing the different possible uses of mycelium in different contexts and applications. Here with us today is Anaïs, who has collaborated in the Research and Development Department of Grown Bio for many years. And Anaïs, thank you very much for being here. We are very excited to discover this fantastic world. And I leave you the floor.
Thank you. Well, great that you're all here and that you show interest for growing materials with mycelium. So we are a small startup of only, at the moment there's 8 people working there. There's a little factory close to Den Bosch. The concept has been started by Jan Berbé in 2016, where he started to find out also about growing with mycelium, and he thought like, wow, this is an amazing product that we can also use as packaging, and it's fully biodegradable. So why is there still styrofoam being used? It's like a very complicated stream that is not recyclable. He started to develop the idea, and eventually, it gained a lot of popularity, and now they create thousands of packaging per month for several companies. We always say grown and not manufactured because there's no manufacturing that comes into the process, but the only thing we actually do is letting the fungi do its work, and we just provide the good circumstances for the mycelium to grow. Yeah, so short, who am I? I already explained you. I'm a mycelium specialist, but also admirer. I think it's an amazing product. There's still so many things to be discovered, so many different kinds of substrates we can use. And we can use it for all kinds of applications, for packaging, for design, for building, and who knows what else. Where do we start? Actually, we start with the problem, which was plastic foams, which are still being used nowadays, also known as styrofoam. This was a big revolution in the 1940s because people started to find out, like, oh, we can make this really fast, really lightweight material that protects our products, and amazing, and they started to really boom this business. But eventually they found out that the recyclability is like not very high, and that it's very complicated to recycle. And even nowadays you cannot even recycle it. There's just no possibility. So the best is to get rid of this and to work with materials that are also based upon renewable resources. So the problem is big. The plastic foam market is about $9.5 billion per year. This is really massive. This would be amazing if we can reduce it by applications such as mycelium that are more sustainable. And styrofoam is occupying almost 30% of the landfill space, which is also not really what we want nowadays. So we have a solution. We have a 100% home compostable material that we call MycoComposite. Myco is from mycology, which means fungi, is a scientific term for it. And we only use 2 ingredients, which is actually agricultural waste and the mycelium itself. So what is mycelium? Mycelium is actually the root structure of a fungi. So if you have a fungi that grows above ground, you actually only see a little piece of it, and most of it is underground. It's a massive network of filaments, and we call it also hyphae, that interconnect all the plants and trees with each other, which is actually what we can see here. It makes any material white because the filaments are also white, as you can see on the picture here. It's a natural decomposer of our planet, so it's a fungi, and fungi, their main advantage is that they decompose anything we have on the long term, and that's why actually there's all these cycles existing from something. The trees fall from the leaf, they're being decomposed by fungi and bacteria, and therefore they are turned into nutrients for the soil, etc. And this is all because of fungi. What is its function in nature? As I was saying before, it's an interconnected network of filaments. So the mycelium itself is only the filaments, but there's another part of it. It's the symbiotic relationship between trees and fungi. They work together. The fungi, they get carbon from the trees, And the fungi, they give nutrients to the trees in return. And so actually the mycelium is an extension of the root network of the plants, which allow them to gain more nutrients in a smaller amount of space, because the mycelium helps them to gain more of what they need. Yeah. So why is mycelium so interesting? It's actually because it's an infinite resource. You can have a little piece of it and it will grow as far as you want. It's underneath our feet, so we don't see it. But if I have a little piece of mycelium, I can replicate it infinitely. So there's no end. And this is something we need these days, especially where we are more focusing upon circularity. Yeah, so when it grows, it starts from a few points where the spores are actually of the fungi, and it can be like in different parts of a substrate that I will show you afterwards. It starts to completely surround the substrate, and if we would leave it growing forever, eventually the whole material is gonna disappear completely. But what we do to create the material is that we stop the growth before it gets decomposed completely. So we stop it at the moment where it is more like this. So here it just started to surround all the fibers, but it didn't get to the point of starting to decompose, because eventually it would start to get smaller and smaller. But by stopping the process of the growth, by drying it, actually it doesn't have any more resources to continue growing. Fungi like wet and moldy spaces. But if you completely dry it out, they cannot continue living. So a small comparison between plastic foam and styrofoam. You need a lot of ingredients for plastic foam, which are not very desirable. They're based on finite resources. They cannot even be recycled, and it requires a lot of energy. Whereas with MycoComposites, we only need 2 ingredients. As I said, it's a natural growing process, so we don't do anything weird. We only need growing chambers to grow the mycelium in different stages of their life. It is fully compostable, so it's approximately 100 days if you pull it apart and you throw it in your garden. But if you throw it in the sea, it will take a little bit longer, but in both environments it's 100% compostable without any harm for the planet. So we try to use as many waste streams as possible. At the moment, we work a lot with hemp because it's also easy to inoculate, and it's at the moment our basic substrate, because it also gives the best results. But in the future, we can also start to look more at grass that's being cut that in the cities, and we don't do anything with it. Maybe we can incorporate it in the substrate as well. So in short, what do? We just have the substrate here. We have to fill the molds, let it grow in the good environment, and eventually we stop the growth by drying it out, and we obtain a material such as this one. I will get a little bit more in the details when we start to grow with the material. So how does it actually start to work? What we have here is already it's called inoculated substrate. So we have hemp fibers here that have already the fungi in it. But before that, something needs to happen. There's companies that are specialized on doing this inoculation of the fungi in the substrate, which is called inoculation of fibers. You can see this little agar plate petri dish, where actually you could go to the forest and find the mycelium of the mushroom you want. You could collect it, grow it in a petri dish, and eventually you sterilize some grains and you put it in a pot and you let the mycelium take over completely. Once you have that, it's called the spawn, which is like the first part of the mycelium growing. You can mix that with the substrate, and eventually then you have a material. You cannot really start growing with only spawn because it is too dense in spores and mycelium, so not a lot will happen with that. So is it possible to mix with different substrates? Yes, it is. We have tried with many things. We have tried sheep wool even, which also works. It doesn't get completely surrounded by the mycelium, but you can definitely integrate it. So there's also ways of finding out how you can put the sheep wool only in the inside and make sure that the mycelium completely surrounds it. Then aesthetically it looks like only mycelium, but inside there's sheep wool for example, insulation. Grass, as I mentioned, Even coffee waste we could use. There's already companies that grow with coffee waste, but they grow more mushrooms for edible consumption, which is the oyster mushroom. Often it is grown on the coffee waste because that type of mushroom likes the coffee waste. We have it here today as well, so we can try to also incorporate it in the substrate, but we have not tried yet in our company because of logistics reasons. If you have a lot of coffee waste, it's difficult to keep it at the good circumstances that it doesn't get too dry, too wet, too moldy, so we prefer to work with something that is more controllable on a larger scale. We have worked with textile as well, so you can imagine that you can grow mycelium, but in the beginning it's very soft and it grows in all directions. So if you have a piece of textile that you put on top or inside of the mold, eventually it will start to integrate the textile, but it will still be visible. So you will see some mycelium filaments getting through it and the textile is completely attached, but it's not integrated fully. So you can actually color the mycelium in a natural way like that, if that's what you're looking for. Also different types of grasses. We can see cattail here, which is also grass that grows a lot in the Netherlands, and people don't do anything with it. We have tried, and we actually use it in the factory as well. So how do we grow? As you can see here, we have molds from, those are recycled PET. It's a type of plastic. But we have these molds because they're good. We use them many times, so we only have to purchase them once. We have growing chambers, as you can see in this picture. Can you hear me if I stand here? If I stand away from the microphone? Because I'm a bit like... Okay. I will just keep it like this then. As you can see here, this is our factory. It's relatively small, still 250 square meters. We have on the right the growing chambers, and in the back we have the 2 drying chambers. So what we do is we fill the molds on the table that you can see here. This is one of our colleagues, Cheert. We start on the right. We bring it into chambers that have around 20 degrees temperature, and it's quite humid, which is the ideal circumstances for the mycelium to grow. After 5 days, we move them to the drying chambers, and approximately after 1.5 weeks, it is fully finished. And then we have just dried mycelium composites. So what are the properties of the end product? It's a fire retardant product. Actually, we have experienced that ourselves as well. In 2019, I remember there was a fire in the factory. Very bad, but because of the mycelium, it didn't gets fired completely. So it just starts to smoke, but it's not like a fire capturing material. It's very lightweight. It's comparable to styrofoam in terms of the weight. It's 100% home compostable. We also say it's CO2 neutral because we actually capture the carbon from the plants that are in the substrate. Of course, there are still some questions because from the moment you start to degrade in your own garden, the composite, it goes back to the nature. But the idea is that the carbon is captured in here, and this is also how LCAs work at the end of the product. It is also water resistant, so if you have a pot, you can also add water inside. It will just stay there once it's dry, of course, the mycelium. It is also insulating in terms of temperature and protective for packaging. So here are a few examples of what we make. We mostly make packaging for cosmetic and luxury brands, candles, perfume, creams, people that are really looking for a more sustainable identity of their brands, and it also looks relatively nice, I think. Here you can see some more. We also work with designers, so you probably maybe know the Growing Pavilion, which you can see here, just standing on the Floriade in Almere, I think, at the moment. We have grown the panels. It's a fungi house. You can go to see it any moment if you like there. We have also grown some pillars for the Milan Design Week, which is the picture in the middle. And also we have worked on another bio-based mycelium house, which is the picture a bit on the left, where we have grown the mycelium panels for the walls as insulation. So what is MycoComposite? It's good for protecting products for packaging. You can also use it for design objects or for building products such as panels for insulation. So what do we do with design? We work with several designers that have made especially lamps that you can see here. We have worked with the Dutch designer Morgan Ruben that has made a very beautiful lamp. You can also see that the lamp is a bit folded. So this was a challenge for us to grow something that is not straight, but like has like a more folded shape. So we had to make sure that's what you see also in the back. The stripes were like molds that were holding the substrate up, so the air could really circulate around it and it was not completely packed. Benches, also biodegradable urns for people that are interested in different ways of getting buried. This is the mushroom collection from Danielle Trophy. She's a designer we work with, and at the moment they have been used in many different types of restaurants all over Europe, by the way. This is Mycel. This is not been released yet. It's a bit inside information, but it's acoustic insulation for a booth where you can go inside, have a call, and it's a bit more silent as outside of it. Made by a Dutch designer. Building products also make, you already have seen this picture in the Floriade. It is, we make these building panels. So at the moment, the building and construction industry is also a problem. They are responsible for almost 40% of the global greenhouse gas emissions. So it would be nice also in the long term if we can work with more sustainable materials. So grow it yourself. We can nowadays do that because we have the technology to also inoculate the substrate and send it all over for people to try it out themselves. So we can start now with the growing process. If you have more questions for Grown Bio, you can always contact Jan. There's his email here, or you can always ask Julia or me for more information. Okay, so exciting step now. I don't know how much you have worked with Mycelium, but it's quite important to work clean, so relatively sterile. It doesn't have to be with lab coats because that's the step before that it happens. The people that make the spawn, they really have like really clean lab and they need to wear the coats and masks, etc. But we don't have that. So the first step is to clean the molds. Okay, so we start with the substrates. We have at the moment the DIY kit. Yeah, disinfecting hands is also very important. So usually the substrate is not this blocky. This is because we have sent it to you a couple of days ago. So it's very important with these type of substances to completely, how do you say this, crumble it out so that it gets really fibrous. We have also brought today some different substrates. So if you like, we can also try to incorporate that and see. You can see afterwards, like in a few days, how that has worked out. So the mycelium, when it comes as a substrate, it always has a specific moisture percentage. It's between 60 and 70. So this is also what it needs to have in order to grow well. If it's too dry, it's not going to grow. If it's too wet, it risks to get contaminated. You can start to fill the molds. But if you want, you can just grab a little bit of coffee waste. So I will tell you when it's okay. For example, this soft skin that we have here, So this soft part was inside the molds. So it creates really different textures depending on.
I thought it
what
was
is
the
in.
other way around.
Yeah, this was in the mold like this.
Yeah.
There is some difference, but yeah, it depends a bit on your philosophy, what you are following as well.
Of course, it's possible to paint this with a natural pigment. I mean, it shouldn't turn white.
Yeah, that is possible.
Do you have any suggestions for?
Yeah, I would say just get creative with the substrates to use and just try out what works, because often startups like Grown Bio or other companies, they don't have like a whole R&D department to try out all the things, and also on the logistics scale it's difficult to incorporate because we just have like one way to grow the products and everybody is used to that way. We cannot just make all kinds of different substrates. But there's a lot that works, as I was mentioning before, working with textile or the sheep wool even. Depending on what you want to reach. But I would say just try out, work sterile, work with a kit like this. And if you really want to get more into it, you can get into making the spawn yourself. So buy the spores and like sterilize grains and you can go as far as you want. But the easiest way is to start with this. Control the growing process, try to incorporate the things you want, make really special molds and see like how it works with the releasing, if you have to release or not. It's all about the timing.
Yeah. Thank you. Any other questions? No? Okay. Well, thank you very much, Anaïs. This was like, very inspiring, I think. And there's indeed a lot of research. And it's like at the beginning of a pathway, I believe. But I think it would be something interesting to play with, like to engage in a playful way.
Yeah, sure, yeah.
Okay. Thank you very much and see you next time.